Hey grade 9s, Mr. McIntyre here. I'm going to do a demonstration for you, kind of showing the electrostatic series and what happens when similar charges are near each other and objects that have different charges come near each other. Okay, so I have this balloon that I've tied to my ceiling light there. I'm going to rub it with some fur that I have. So if you take a look at the electrostatic series chart, you'll see that fur has a weaker hold of electrons than rubber, which is what this balloon is made out of. So if I rub this fur onto this balloon, it should make it very negatively charged because this loses electrons easily and the rubber likes to hold on to its electrons. So if I rub these two things, this will become negatively charged and this will become more positively charged. So let's try it. I'm just going to rub all over this balloon. Hopefully I don't pop it. Okay. Alright, yeah, it's sticking to me. It's very charged here. Okay. Now let's try bringing something close to it. So I have a piece of plastic here. I am going to do the same thing with the plastic with the fur. I'm going to rub the plastic rod with the fur. Again, plastic is better at holding on to electrons than the fur. So the electrons are going to be coming from the fur onto the plastic here. So if this is going to be negatively charged and our balloon is negatively charged, we bring it close, it should repel each other here. Alright, that's exactly what we got. You see it when I'm coming close? Oh, it's coming closer to my hand, but it's pushing away from the rod. Alright, now let's try another balloon. I have another balloon here. I'm going to do the same thing, rub the balloon. I can hear the charge when I'm rubbing it. So again, the fur does not hold on to electrons well, whereas the rubber holds on better. So that means that the electrons are going to be on this balloon, which makes it negatively charged here. So I'm going to bring it close to the other balloon, and if that is negatively charged and this is negatively charged, let's see what happens. Oh, I can see it already. I'm not even coming that, there we go, look. They repel each other big time because they have the same charge, the same kind of negative charge, so they're going to repel from each other. Alright, let's try something else here. So I have a glass rod. So a glass rod holds onto electrons. It has a very weak hold onto electrons, even weaker than this fur. So if I rub this glass rod through this fur, the electrons are going to moving from this glass rod to the fur. So when you lose electrons, it's going to become more positively charged. So the electrons were going from the glass rod to the fur because the glass holds on to electrons worse than the fur does. So this will be positively charged. I can move this towards the balloon, which is negatively charged, and we'll see if they attract. Alright, so it likes it. It likes the glass rod here. So it's attracting because they have different charges. Alright, what else do I got here? Okay, something else that has a weaker hold on electrons, that's higher up on the electrostatic series, is wool. So wool is higher up than fur, so if we rub them together, we should expect this wool sock, this piece of wool sock, to be more positively charged because it's going to lose its electrons because it has a weaker hold on its electrons. So the fur is going to gain electrons and the wool is going to lose its electrons. And when you lose electrons, you're losing negative charge, so it's like subtracting a negative, so it's like a positive charge. So if this is positive and this is negative, I should hold it up, and it's going to attract. Because the balloon is negatively charged, and we just gave this wool sock a positive charge by rubbing with the fur.